Hi, I'm Ravi and I'm going to talk about my project Pipeline Leak Detector based on vibrations. This will be the outline of my presentation. We will discuss about my prototype, the hardware and software that I used, and the working of the system along with some challenges that I faced. So let's jump right in. By the way, these images depict the effects of leaking pipelines. They result in a lot of adverse effects, both economically and environmentally. So let's start. Our need to transport fluids from the point of production to the area of end use has led to a rapid increase in the number of pipelines being designed and constructed. Many of these carry toxic and hazardous products, often close to the centers of high population or through areas of high environmental sensitivity. With the need to safeguard these lines, an online monitoring system is essential, and in some cases 24-hour surveillance is mandatory. Most often, these pipelines carry fluids for long distances with high pressures. There are different methods to detect leaks in pipelines as shown in the figure, but most of those cannot detect leaks in all kinds of pipes carrying all kinds of fluids. But vibration analysis can be done irrespective of the pipe and fluid material until there is substantial pressure inside the pipe. Alright, so to detect a leak in any kind of pipe carrying any kind of fluid, what do we need? This whole system is based on the fact that a leak in a pressurized pipeline introduces vibrations in the pipe that can be detected, and in turn leak can be detected. In order to do this, we need a sensor that will be able to detect the vibrations in the pressurized pipe. We have piezoelectric sensors and accelerometer sensors that can be used to detect these vibrations. But an accelerometer sensor is the perfect sensor for us because of its size and ease. And we need a processor that can receive signals from the sensor and process them to detect the leak. After detecting the leak, we have to communicate it to the outside world so that a person will be alerted and will hopefully respond soon to stop the leak. To do this, of course, we need a communication module. As a choice of accelerometer, ADXL362 was chosen. And to process the signals, a Raspberry Pi was chosen because of its ease to connect with other modules like the sensor and the internet. Of course, for which a Raspberry Pi Wi-Fi module will be used. However, after consuming a lot of time and taking a few hundred readings, it was observed that the accelerometer ADXL362 is incapable of taking the readings of vibrations in the pipeline that is used as a testbed, whose details are mentioned in the report. This accelerometer often has an error of around plus or minus 5, which is in the order of the magnitude of the vibrations of the pipe. So, after a bit of research, a much sensitive sensor, MPU 6050, was chosen. This sensor is of plus or minus 16G sensitivity, while ADXL362 is only a plus or minus 8G sensitive. It also outputs 16-bit signals when compared to the 12-bit words of its predecessor. For the software part, as we chose Raspberry Pi, it will be much better to use Python. Initially, MATLAB was expected to create a standalone Raspberry Pi using its signal processing toolbox. But because of the other functionalities of the system like emailing and uploading real-time data, MATLAB lost to Python. To interface the sensor to the Raspberry Pi, SPI communication is required for the ADXL362 and I2C communication is required for the MPU 6050. These libraries were found on the internet and were understood, and required modifications were made. The next part is to process and detect the leak. To do this, we need to calculate the FFT, for which we need the SciPy library of Python. The email code utilizes the SMTP-lib Python library, and for uploading the data to the Google Drive, a mechanism was found on the internet for uploading the videos and using Google APIs. This code was completely understood and modified to upload text files rather than the video files. The working of the system can be divided into three stages. The data acquisition stage is when the data of vibrations is recorded in the Raspberry Pi. In this stage, the vibration patterns for no leak conditions and different leak conditions will be recorded, and a threshold will be decided. And then, in the real-time stage, the real-time data will be recorded and the FFT will be calculated. Then, the data is stored in the text files, and these text files are uploaded to Google Drive. Then, the obtained data will be subtracted from the ideal no-leak data that was obtained in the previous stage. This is done to remove the noise in the vibration data and to ignore the vibrations introduced by the ambience. Then, the threshold will be applied to the subtracted spectrum. If the magnitude of any frequency is crossing the threshold, It means that these are the frequencies that are being affected by the leak. Then the emailing code will be triggered to send the alert email, which is the IoT stage of the system. As mentioned before, a mistake was made in choosing the accelerometer initially, and finally MPC 6050 was chosen. Noise also created a problem which was compensated by taking the difference of the spectrum that removed most of the noise, and then some filters were applied to remove the white noise that was observed in the signals. Coming to the results, the waveforms shown here are the different spectra of all the axes of the accelerometer. The spikes that can be observed in the X and Z axis are because of the leaks. When a threshold is applied to the spectrum, it can be classified as a leak, as the particular magnitude of the frequencies which are created by leak are crossing the threshold. The demonstration video of the system detecting the leak can be found in the link shown below. This system can be used to detect leaks in all kinds of pipes and can be used for 24-hour surveillance. A number of extensions can be made on this system, which will be very helpful. When deployed commercially, a number of these devices were expected to be installed on a pipeline at regular intervals. The distance of these intervals can be determined depending on the material of the pipe, because the distance to which vibrations travel in the pipe depends on the material of the pipe. Whenever a leak is detected, the device alerts the maintenance team with the location of the leak. That can be calculated from the vibration magnitudes observed at two adjacent devices. And the device will immediately stop the pumping and will be capable of closing a nearby valve to contain the leakage amount, if the pump and valve are also a part of IoT. This system decreases the environmental and economical impact of the leak to a greater extent. Thank you.